Max and Min love playing sport, and they are very active members of their local sports club. Recently, the twins were asked by a club committee to help them work out which sports were the most popular with players. Both Max and Min had observed over the previous year that soccer, netball, cricket, and Aussie rules seemed to be the sports most played at the club. However, they decided that to get accurate information about this, they needed to conduct a survey amongst all club members. So, Min, Max said, as they discussed what they would ask in their survey, finding out what sport people play is collecting categorical data. If we were asking people how many sports they played, that would be collecting numerical data. Correct, Max. Basically, word answers to survey questions are categorical data and number answers are numerical data. So what survey question do you think we should ask the club members? Well, Min, answered her brother, we know which 4 sports are the most popular just from our observations. We should simply ask all 216 club members which of those sports they play, then tally their answers to work out how many people play each sport. And Max, Min added, we need to remember that many people play more than one sport, and some play sports other than the 4 most popular. It's okay that people play 2 or more sports, Max replied. We will still find out the order of popularity from their answers. As for the people who play other, less popular sports, we can add a category called Other. Good thinking, Max. So let's write the question. The twins wrote out the following question. Which of the following sports do you play at our club? To make sure none of the sports were left out, they added, state all that apply: soccer, netball, cricket, Aussie rules, other. Over the next week, the club sent this survey question by email to all club members, and all 216 replied with their answers. The twins were given the answers, and they entered the data into a simple spreadsheet they set up on their tablet, which looked like this when they finished. The sports played, including other, are listed in the left column, and a tally of the number playing each sport is in the next column. Note that there is a total of 364 players, even though there are only 216 club members, because many of the members play more than one sport. In previous Topic 7 videos, Max and Min drew data tables, graphs, and charts by hand. But this time, they used a computer spreadsheet to display their data because they knew they would also be able to quickly generate various colored graphs for the club committee to look at. Within a couple of minutes, they created on their laptop this column graph and this pie chart displaying the information. The twins had learnt at school that these types of data displays are very suitable for quickly comparing visually the various data collected. Note that each display has a title and each sport and its number of players is clearly labelled. On the column graph, the vertical axis has equal spaces marked to show the number of players, and beneath the horizontal axis, Each column has its sport written underneath it. The pie chart has a key along the bottom which gives each sport a color. The committee at the sports club would be able to use this data to decide what sports and how many teams to organize for the next year. Creating these graphs reminded the twins of the line graphs and dot plots they had drawn up in class. Dot plots are similar to the picture graphs they drew in videos 2.71 and 4.71. However, instead of using pictures to display the data, dot plots use dots. Like picture graphs, dot plots are best used when the data are small whole numbers or multiples of the same number. For example, in this dot plot, we are told that each dot represents 3 students. So we can see that 15 students, that is 5 dots times 3, receive $2 weekly pocket money, while only 6 students, 2 dots times 3, receive $4 per week. Since each dot represents 3 students, adding up all the dots, then multiplying by 3, will tell us how many students were included in the survey. There are 15 dots altogether, so 15 times 3, that is 45 students took part. All the data, represented by the columns of dots, are multiples of 3. On the other hand, Max and Min learned that line graphs are best used to display continuous change. That is, numerical data such as daily temperatures, like in this graph here, or the ongoing height measurements of a growing child. That kind of data is continuous. If, as in this graph, the temperature measures 16 degrees Celsius at 10 a.m. and then measures 18 degrees Celsius 2 hours later, then we can definitely say that the temperature was 17 degrees sometime in the 2 hours between. That is why we can draw the line graph between the measured points, even though the temperature was not actually measured at every hour. Try creating a spreadsheet on a digital device to record data, then generate different types of graphs from it. Now you can watch this video again or try the quiz and look at the chart that comes with this video.